Okay. Good afternoon, everyone. We are Team NextGen, and today we're proud to present our project FormIQ, the intelligent receipt parser. So we are a team of 4 people. I am Apurva. I have my friends Chandni, Manjunatha, and Praful. So our project is FormIQ, which is nothing but a intelligent receipt parser. This project addresses a common yet persistently challenging problem, which is nothing but like automating the extraction of structured data from everyday receipts, including handwritten ones. Our application goes beyond traditional OCR. It combines state of the art text recognition with a language model to understand and organize receipt content. Plus, it also supports natural language queries via an integrated chatbot. FormIQ is just more than like an OCR tool. It is a full stack MLOps solution that brings intelligence to the receipt digitization process. So, this is the index and this is the agenda for today. So, we're going to go through all of these one by one. So let me start with the problem statement. So the problem we are solving is both complex and simple in like surprisingly complex way. And the first thing that we do is like the manual data entry from receipt is like tedious, slow, and prone to human error. Businesses often spend hours trying to extract fields like dates, vendor names, or totals from stacks of like paper receipts. Second, when it comes to like traditional handwritten receipts, traditional OCR engines like Tesseract fail to deliver high accuracy. So this becomes a real world challenge in global markets where printed forms are always not standardized and people can still have like handwritten receipts. And the third thing that is the problem is like automation is missing. Most available tools can extract text, but they don't organize it to like a usable structure. So uh, it's not always in the structure that we are expecting. So it makes the downstream analytics difficult. The fourth thing is like existing systems do not support natural language querying. So this means like the users can't just ask how much did I spend at Walmart last month and expect an answer. So the core challenge here is like how do we extract, structure, store, and like make receipt data queryable, all in a single unified platform. So that is where our project FormIQ comes in. So this is our proposed solution where our solution is a modern AI-powered web application that automates the receipt processing lifecycle end to end. We use Paddle OCR as our primary engine for recognizing both printed and handwritten text with high accuracy. The extracted raw text is like then passed to the Perplexity LLM, chosen for its robust capabilities in understanding and structuring textual data, which restructures it into a JSON format, which is nothing but like a structured format which is understandable by the machine by mapping fields like date, vendor, item list, and also the amounts. We store the structured data in AWS DynamoDB, which gives us serverless, scalable, and low latency access to like receipt records. And also users can also like ask questions about their receipts via chatbot built using Fast API, which translates the natural language into Patio QL queries, retrieves the answers, and presents them in real time. And also, like the final thing to make the system more transparent and trainable, we added an evaluation model, training demo that visualizes model accuracy, loss curves, and confusion matrices right within the app. All of this is integrated through a clean, streamlit interface, making our FormIQ a one-stop solution for receipt intelligence.
Yeah, coming to the tech stack, this represents the technical foundation of FormIQ. Our solution leverages a diverse and robust stack of modern technologies to ensure accuracy, scalability, and usability. For the front end, we use a Streamlit. It is a fast, lightweighted program framework, ideal for building interactive dashboards. It handles file uploads, model interaction, and chatbot communication in a single page UI. For OCR, we used Paddle OCR because it excels in multilingual and handwritten recognition, which is essential for diversity of receipt formats. The LLM parser is powered by the Perplexity LLM, and it converts raw text into structured JSON format, which identifies fields such as item names, quantities, prices, and totals. For our backend, we have used a Fast API, which is a high performance Python web framework. It serves as a bridge between the front end LLM and the database, enabling seamless interactions. Structured data is stored in AWS DynamoDB, which offers a real-time SQL storage. It is basically optimized for low latency access and allows scalable, flexible schema design. For evaluation, we use Matplotlib and Seaborn to visualize accuracy loss, and confusion matrices. Finally, we used Perplexity API for um, chat interface to enable natural language interactions over stored receipt data. The next slide. Coming to the system architecture, the flow begins with Streamlit UI, where users can upload the documents or images like receipts. Once a file is uploaded, it is sent to the text extraction model, which uses the OCR to detect both the printed and handwritten text. This raw text is then passed to the LLM structuring block, where Perplexity AI transforms it into structured JSON format. The structured data is stored in AWS DynamoDB. In parallel, we have a model training and evaluation module also accessible from the UI only, which supports experimentation and many demos. The Fast API backend connects all the components. It facilitates communication between the UI, Perplexity LLM, and DynamoDB and the chatbot. The chatbot accesses DynamoDB through Fast API to handle the user queries using LLM generated logic. This modular architecture ensures fault tolerance, scalability, and smooth user interaction. The next slide is like working of OCR. Here is a simplified breakdown on how OCR works in our pipeline. First of all, it start by converting input image to grayscale to reduce the computational complexity and reduce the noise. And then the system identifies regions of the image likely to contain text. The detected regions are cropped to isolate text areas, improving downstream recognition accuracy. A neural network reads characters from the cropped segments. This is where the paddle OCR excels, specifically for cursive or low resolution text. The next one is decoding. The model raw output is decoded into human readable characters. Finally, the system combines all the recognized segments into a continuous structured output. This pre-processing ensures that even faint, noisy, or non-standard receipts are legible to rest of our pipeline.
Yeah. So after that, like we'll be moving on to the structuring the like OCR data. Like after the OCR engine extracts the data from the text from the receipts, the next challenge is to making the data usable. The OCR output is just a string of characters. It lacks the structure, meaning, and the context of it. That's where our integration with the Perplexity LLM comes in, which we use the LLM to take a unstructured text and convert into convert it into the JSON format. This JSON contains a field such as the data, the total amount, and the product names, and the quantities, etc. As shown in the example on the right, so this is the data structure, like data like was in a JSON format, and as shown in the example here, the organizers structures in a cleaned and machine readable structure. This stored output is not only easy to store and retrieval also enables a user to run analytical and answers in natural language in questionnaires. So technically, this is integration is seamless. Our backend makes a single API call to LLM with a prompt, and that will return a JSON output for this. If you go to the next slide, then we have a DynamoDB structured data storage. Once we have a structured JSON, we store it in Amazon DynamoDB, which is fully managed in NoSQL database. So this DynamoDB is ideal for our use case because it offers low latency read and writes even at scale. Each receipt is stored in a documented with a unique key, which makes it easy to retrieve records based upon the field or receipt number or dates. So this makes a DynamoDB a perfect match for LLM outputs, which can vary depending upon the receipt complexity, whether it's a human written or it's a text written. As we also rely on a DynamoDB real-time querying capabilities for chatbot interactions and backend analytics. So whether the user wants to view the raw data or a filter by vendor or ask a natural questions, the responses is immediate from the perplexity and the DynamoDB combined. So next we go on to the model training and evaluation. So in this behind the document processing, we include the training model to demonstrate the evaluation and MLOps transparency. This part adds a training a lightweight convolutional neural network on a synthetic data to classify documents into three categories. As you can see on the left graph, we have a plotted trainings on the validation loss alongside to the accuracy, like over the 10 approaches it was run. The validation accuracy improves the significantly at the reaches around 82% at the end, with decreasing loss curve indicating the good convergence. So on the right hand side, if we can see the confusion matrix format for final approach, so it shows the model prediction versus the actual labels. So most of the prediction and accuracy is a very misclassification, and so in additional to being a production ready tool, so this demo is not only gives the user so insights to the model performance, but also gives us the showcase self-contained ML pipeline with an integration with the Streamlit UI. So from here, the Praful will be continuing the next part.
So we will be looking into one of the most exciting features of FormIQ. This is our built-in receipt chatbot, which enables natural language query and answering over the received data that we have uploaded. So the chatbot is powered by a fast API backend. It listens for user queries and then parse them and translates them into the intended structure action, which was JSON. For instance, if a user asks what was the total amount paid on January 1st, 2018, so the chatbot retrieves the matching receipt record from DynamoDB using PartQL. Then it sends the relevant data and the question to Perplexity API, which returns a concise and accurate answer to the question. This makes it easy for user to gain actionable insights without knowing SQL or scanning spreadsheets. The entire process is real time and it runs seamlessly inside the Streamlit UI, making it feels like interacting with a smart virtual assistant. This integration adds immense value for non-technical users and brings an intelligent layer of interactivity to our application. So next in the next slide, we'll be discussing about the deployment. So we have used Hugging Face spaces. So to ensure our solution is publicly accessible without any local setup, we have deployed FormIQ on Hugging Face spaces. The deployment includes both the Streamlit-based UI and the fast API backend. This was fully containerized, and we are using version control offered by Hugging Face spaces via GitHub. What this means is that anyone with internet access can test our app, upload receipts, interact with the chatbot, and run the model training demo without needing to install anything locally. So the backend is securely connects to both the Perplexity API and DynamoDB. So all interactions and Q&A sessions are live. This deployment also demonstrates end-to-end MLOps readiness, including continuous integration and support for scalable and serverless operation. Hugging Face Spaces gave us a frictionless path to showcase our application with full cloud functionality. Moving on to the user interface. Now let's have a quick look how our user interface looks like, which is very clean and responsive. And at the top, we have a drag and drop file upload option, which supports PNG, JPG, JPEG, and PDF up to 200 MB. Once a document is uploaded, the user can view extracted results initiate the chatbot queries from the sidebar, or launch the model training and evaluation module. There's also a setting panel that lets user adjust the confidence threshold for model inference and choose document types like invoices or handwritten notes. All of these interactions happen in a single page interface, which means there's no need to navigate between tabs or windows. So, in summary, the UI brings together all the system components, OCR, LLM, database, chatbot, and visualization into a seamless user-friendly interface. In the next video, we'll be discovering the demo part of this application.